Hi students, good morning to all of you. So in the last class, we have discussed about who is an engineer. So who can we define engineering? So we have defined engineering drawing, and also we have discussed about definition of the engineering drawing, definition of the engineering graphics, and also we have discussed about drawing instruments in detail. So today in this class, we are going to discuss about the same topic. So this is class 2, that is introduction about engineering drawing. So today in this class we are going to discuss about these topics. So first one is types of engineering drawing, role of engineering graphics, practical applications of engineering drawing, drawing sheet layout, title block representation, types of lines, dimensioning system, types of dimensioning. So in this session we are going to discuss about these topics. So let us see one by one. So first one is, what is the topic? First topic, types of engineering drawing. Types of engineering drawing. See, basically we have 4 types in engineering drawing. So they are geometrical drawing, second one mechanical engineering or machine drawing, third one civil engineering drawing, fourth one electrical and electronics engineering, drawing. So these are the 4 types we have. So let us see one by one. What is geometrical drawing, what is mechanical engineering drawing, what is civil engineering drawing, what is electrical and electronics engineering drawing. So let us see one by one. So first one is what? Geometrical engineering drawing or geometrical drawing. So first one, see, geometrical drawing includes, so what are the geometrical figures? Rectangle, square, cube, cone, cylinder, so etc. So these are all comes under geometrical objects. These are all comes under geometrical objects. So in geometrical drawing, again we have 2 types. So first one is plain geometrical drawing, second one is solid geometrical drawing. So let us see what is plain geometrical drawing. So plain geometrical drawing is nothing but it is a 2-dimensional drawing. It is a 2-dimensional drawing having length and width only. Once again listen, plain geometrical drawing is a 2-dimensional drawing having only length and breadth. So example, square and triangle. So this is a square shape, this is a plain geometrical drawing, and this one is a triangle, a rectangle. So it is these having only length and breadth, okay. So these are all plain geometrical drawings. Next, second type in geometrical drawing, second type is what? Solid geometrical drawing. Solid geometrical drawing. So what is solid geometrical drawing? What is solid geometrical drawing means? Solid geometrical drawing is nothing but it is a 3-dimensional drawing. Solid geometrical drawing is nothing but it is a 3-dimensional drawing having length, breadth and thickness. It is a 3-dimensional drawing having length, breadth, thickness. Examples, cone, prism, cylinder, etc. Cone, prism, cylinder, etc. So this is a cylinder. So this is a cylinder and this one is prism and this one is a cone. So these are the examples for the solid geometrical figures, solid geometrical drawing. Next, second type is what? Mechanical engineering drawing. Mechanical engineering drawing. See here. So mechanical engineering drawing nothing but what? So under the mechanical engineering drawing, so we have machines and machine parts. Means machines and machine parts etc. comes under mechanical engineering drawing. Machines and machine parts comes under mechanical engineering drawing. So this is a machine and machine parts. These are the machine parts. Machines and machine parts comes under mechanical engineering drawing. Next, third type is what? Civil engineering drawing. Civil engineering drawing. So civil engineering drawing, roads, buildings, bridges, dams. So these are all comes under civil engineering drawing. Once again listen, roads, buildings, bridges, dams. So these are all comes under civil engineering drawing. So these are the roads of different shapes, road design, building design, and dam design. So these are all etc. These are all comes under civil engineering drawing. Next, last one, fourth one, that is what? Electrical and electronics engineering drawing. Electrical and electronics engineering drawing. So under the electrical and electronics engineering drawing, so transformer, wiring diagrams, printed circuit boards, IC means integrated circuits, etc. These are all comes under electrical and electronics engineering drawing. Once again listen, transformer, wiring diagrams, printed circuit boards, integrated circuits. So these are all comes under electrical and electronics engineering drawing. Okay, means the electrical and electronics people will design these objects: transformer, wiring diagrams, printed circuit boards, and integrated circuits. So this is a printed circuit board, and this one is an integrated circuit, and we have also transformer and wiring diagram also we have. So these are all comes under electrical and electronics engineering drawing. So these are the main types of the engineering drawing. And next topic is what? Role of engineering graphics. So what is the main role of engineering graphics? Means visualization, communication, and documentation. Role of engineering graphics is nothing but first we have to visualize an idea, next communicate that idea, and we have to document that idea. So that is the main role of the engineering graphics. Next topic is what? Practical applications of engineering drawing. Practical applications of engineering drawing. See here we have number of applications of engineering drawing. So in the mechanical engineering field, we have some of the applications. They are machine components, transmission systems, CNC machines, robotics. So these are all comes under mechanical applications. Once again listen. So machine components, transmission systems, CNC machines, robotics. So these are all comes under mechanical applications. Next, in civil applications we have they are, see here, this is robotics design, machine parts. So these are all comes under mechanical applications. Next, second type is civil applications, civil engineering applications. See here, this is also mechanical engineering application, and this one also application of engineering drawing in ships, aeronautical engineering, mechanical engineering applications. Next, second one is applications in civil engineering, applications in engineering drawing, applications in civil engineering and architectural engineering. So structure, plan of building, bridges, stadiums, town planning. So these are all comes under civil engineering applications and architectural engineering applications. Next, we have some another applications. They are in the field of electrical and electronics field also. This is a stadium design, building designs. So practical applications of engineering drawing. circuit layout, electrical wiring, panel board design, and electrical engineering. So in electrical engineering, see here, this is a circuit layout. So if you want to design a printed circuit board or circuit layout, first we have to design that diagram. So this is circuit layout. So in the field of electrical engineering, so wiring panel and the panel board design, this is a panel board. Okay, so these are all applications in the electrical engineering field, in the electrical engineering field. Next, printed circuit boards, microprocessor, integrated circuits, so etc. in computer science engineering and electronics communication engineering. So this is a printed circuit board, and this one integrated circuit. So these objects designed by the CSE people and electronics students, okay, EC students and CSE students. So these are the some of the applications of some of the applications in the computer science engineering and electronics communication engineering. Next, we have some more applications. Fashion design. In the fashion design, in the design of garments, okay, clothing, garments in textile engineering. So these are the practical applications of engineering drawing in the various fields, in the mechanical field, civil field, and architectural field, and electrical engineering field, and textile engineering field. So these are the some of the practical applications of engineering drawing. Fashion design, clothing, garments in textile engineering. So these are the some of the practical applications. So next, let us see drawing sheet layout. Drawing sheet layout. So this is a drawing sheet layout. So this is our main drawing sheet. So in that, this is a borderline. This is a borderline. So borderline, we have to draw the distance of 3 centimeter from the outer edges left side, from the left side. So this distance is 3 centimeter, and this one is 2 centimeter, and this one is also 2 centimeter, and this one is 2 centimeters. So in the drawing sheet, bottom side, right side bottom corner, so we have to draw the title block. So the title block distance, title block measurements are 150 mm into 50 mm. 150 mm into 50 mm. So this is a drawing sheet layout. Next, title block representation. So already we know that title block representation, title block measurements, so 150 into 50. See here, so this is a 50 distance. So we have to divide this 50 into 5 equal parts, means 10 mm, 10 mm, 10 mm. This part is 10 mm, this part also 10 mm. So this is for name writing. This is for this box for roll number, section, date, and grade. So these are the 5 parts. And next, vertically we have to divide this one 3 parts. Total distance is 150 mm. From here to here 50 mm, remaining 50 mm. Next, third part is also 50 mm. So this is for lines and lettering purpose. This box is sheet number. So this is a faculty signature box, and the drawing representation, first angle projection representation. So this distance is 10 mm, 10 mm, 10 mm, and remaining is 20 mm. Okay, and this is about title block representation. Next, types of lines. So basically, in the engineering field, we have different types of lines. So next topic about types of lines. Next topic about types of lines. So here in the engineering drawing, we have different types of lines. They are continuous thin lines, Second one, continuous thick line. Third one, dashed thin line. Fourth one, long dashed dotted thin line. Fifth one, long dashed dotted thick line. And sixth one is zigzag line. Seventh one is continuous thin freehand line. So these are the lines generally we have in engineering drawing. So let us see one by one. What is the first one? First one is continuous thin line. See, what are the applications of the continuous thin line? Let us see one by one all these lines. See, first one is what? Continuous thin line. So this is a continuous thin line. So here we have a tabular form, serial number, line description and representation, applications of the particular line. See here, line description means name of the line. Representation means figure, diagram, that particular line diagram. See here, continuous thin line, this is a description, representation is this one, this is a continuous thin line. So what are the practical applications of the continuous thin line? So continuous thin lines are used to draw dimension lines, extension lines, leader lines, reference lines, short center lines, projection lines, hatching lines, construction lines, and imaginary lines. So here, if you want to draw these lines, dimension lines, extension lines, leader lines, reference lines, short center lines, projection lines, hatching lines, construction lines, and imaginary. If you want to draw these lines, we have to use continuous thin line. So this is about continuous thin line. So students, you may ask one question: what is dimension line? What is extension line? What is leader lines are? So I will explain later. I will show you later in the next class. First, you listen carefully. So okay, so this is the first line. And what is the second line? Second line is nothing but continuous thick line. This is second one, second line type, continuous thick line. So continuous thick lines are used to draw visible outlines and visible edges. If you want to draw the visible edges and visible outlines, or visible edges and visible outlines, if you want to draw these two lines, we have to use continuous thick line. And third one is what? Dashed thin line. Third one is dashed thin lines. So this is a line representation, dashed thin line. So dashed thin lines are used to draw hidden lines. So this type of line is used to draw hidden lines and hidden edges. I will show you later in the next class. First listen. So here, if you want to draw the hidden lines and hidden edges, we have to use dashed thin line. This is a dashed thin line diagram. Okay. Next, fourth one is long dashed dotted thin line. See here, long dashed dotted thin lines are used to draw center lines, axis lines, lines of symmetry, and cutting planes. So if you want to draw these four lines, we have to use long dashed dotted thin lines. So this is long dashed dotted thin line. This is long dash dot, long dash dot, long dash dot, like this. This is long dashed dotted thin lines. Next, fifth one is what? Long dashed dotted thick line. So long dashed dotted thick lines are used to draw cutting planes at the edges and ends changes. and second line is direction of outlets. So direction of outlets and cutting planes at the edges changes. So if you want to draw these two lines, we have to use long dashed dotted thick lines. I will show you later. Next, sixth line is what? Continuous zigzag line. Continuous zigzag line. This is zigzag line. Continuous zigzag line. So continuous zigzag lines are used to draw long break lines. If you want to draw long break lines, so we have to use continuous zigzag line. This is continuous zigzag line. Next, last one. What is last one? Continuous thin freehand line. Continuous thin freehand line. Continuous thin freehand line. So continuous thin freehand lines are used to draw freehand curves. So if you want to draw the freehand curve, this is a freehand curve. This is a freehand curve. So if you want to draw the freehand curve, so we have to use continuous thin freehand lines. So this is about types of lines. Next topic is what? Next topic is dimensioning. So this is a tabular form. Different types of lines and general applications of those lines. Different types of lines and applications of those lines. Next, types of dimensioning. Types of dimensioning. So what is, first of all, what is dimensioning? What is dimension? How can we define dimensioning? Means the numeric value of length or angle is known as dimensioning. Once again listen, the numeric value of length, or angle is known as dimensioning. So basically we have three types of dimensioning systems. So that is, they are what? They are chain dimensioning, parallel dimensioning, combined dimensioning. Chain dimensioning, parallel dimensioning, combined dimensioning. See here, so a drawing without dimensioning is meaningless. That's why we have to maintain necessary dimension to show exact size of the object. If you want to show the exact size of the object, we should maintain necessary dimension. Dimensioning. So here there are three types of dimensioning. So they are chain dimensioning, parallel dimensioning, combined dimensioning. So let us see one by one. What is chain dimensioning? What is chain dimensioning? See here, if we arrange the dimension lines in a straight line manner, then the dimensioning is known as chain dimensioning. This is about chain dimensioning. So here, this is a main figure. So for this main figure, this is extension line. So this is an extension line. This is another extension line. So this one is extension line. This one is extension line. This one is extension line. This one also extension line. And this one is arrow symbol, arrow symbol, arrow symbol, arrow symbol. In between two arrow symbols, we have a one line. So this is called dimension line. So this is one dimension line. This is another dimension line. Third dimension line. Fourth dimension line. Fifth dimension line. See here. So here, this first dimension line is second dimension line, third dimension line, fourth dimension line. So these four dimension lines are in a sequence, means in series manner, means in a straight line manner. So that's why it is a chain dimensioning. Okay. Once again listen, what is chain dimension? Means if we arrange the dimension lines in a straight line manner, means so this line is first dimension line and second dimension line, third dimension line, fourth dimension line. So four dimension lines are in a straight line manner. So that's why this type of dimensioning system is called chain dimensioning. So this is about chain dimension. I hope you understand. Next, second one is what? Parallel dimensioning. Second one is what? Parallel dimensioning. What is parallel dimensioning? So if we arrange the dimension lines in a parallel to each other, if we arrange the dimension lines parallel to each other, then the dimensioning is known as parallel dimensioning. See here, this is the first dimension line, second dimension line, third dimension line. So first dimension line is parallel to second dimension line. Second dimension line is parallel to third dimension line. Here, these three dimension lines are parallel to each other. So here, this one is parallel to this one is parallel to this one. Means here these three parallel lines are dimension lines are parallel to each other. So that's why it is called parallel dimensioning system. What is parallel dimensioning means? Once again listen, if we arrange the dimension lines parallel to each other, then the dimensioning is known as parallel dimensioning. This is a parallel dimensioning system. Okay, next third one, combined dimensioning. So combined dimensioning, what is a combined dimension means? So when both method means, so chain dimensioning and parallel dimensioning, both methods are used on the same diagram. The method of dimensioning is called combined dimensioning. See here, so for this figure, so we have both dimension systems. So this one is chain dimension system. So here this dimension line is parallel to number 8 dimension line is parallel to this dimension line. So these two dimension lines are parallel to each other, and this one is parallel to this one, and this dimension line is parallel to this one. So these two lines are parallel to each other. This is a parallel dimension system. So here this dimension line is parallel, this first dimension line, second dimension line, third dimension line. So these three dimension lines are in a straight line manner. So this is a chain dimensioning, and these two parallel dimensioning. So for this diagram, we have drawn two dimensioning systems, parallel dimensioning and chain dimensioning. So if we use two dimensioning systems, chain dimensioning and parallel dimensioning, at a time for a single diagram, so that is called combined dimensioning. So this is about combined dimensioning. Next, dimensioning system. So there are two types of dimension system: aligned dimension system, unidirectional dimension system. Aligned dimension system and unidirectional dimension system. So let us see what is aligned dimension system, what is unidirectional dimension system. Let us see one by one. Okay, next topic is dimensioning system. So there are two types of dimension systems. First one is aligned dimension system. Second one is unidirectional dimension system. First one is what? Aligned dimension system. Second one is unidirectional dimension system. So let us see one by one. What is aligned dimension system? What is unidirectional system? So let us see one by one. So first, what is aligned dimension system? See here, what is aligned dimension system means? So if we want to understand the aligned dimension system, we should keep 3 points. In our mind. So first point. So what is the first point? See here, the dimension value is placed perpendicular to the dimension line. Always the dimension value is placed perpendicular to the dimension line. This is the first point. And second point is what? The dimension value should be placed near the middle of the dimension line. First point is what? Once again listen. The dimension value is placed perpendicular to the dimension line. The dimension value should be placed near the middle of the dimension line. And the third point is the dimension value always placed above the dimension line. We should place the dimension value always above the dimension lines. So this type of dimension system is called aligned dimension system For example, the diagram will be like this. See here, this is a aligned dimension system diagram. So see here, this is one dimension line, this is another dimension line. So this is the one dimension line, so another dimension line. So here, if we observe this figure, so here the number 50 is placed above the dimension value. The number 50 is placed above the dimension value, and this 50 value is perpendicular to this dimension line, and this number 50 is at middle of this dimension line. So that's why it is a aligned dimension system. Once again listen, what is aligned dimension system means? Here the number 50 is the dimension value, so this dimension value is perpendicular to this dimension line, and this dimension value is placed middle of this dimension line. So for example, from here to here this distance is 50 mm distance, so we should place this number middle of this distance, and always we should place this number above the dimension line. So this is above, this is below. Always we should place above the dimension line. So if we keep these points like this, so then the dimension system is called aligned dimension system. Okay, next second type is what? Unidirectional dimension system. See, second type is what? Unidirectional dimension system. So if you want to understand unidirectional dimension system, we should keep 2 points in our mind. So they are, first point is what? In the unidirectional dimension system, first we have to cut the dimension line. At middle. And second point is what? We should place the dimension value at middle of the cutting portion. That type of dimension system is called unidirectional dimension system. So once observe this diagram. See here, this is a diagram for unidirectional dimension system. So here, this is a dimension line. So in unidirectional dimension system, we have to use 2 points. So first, what is the first point? We should cut the dimension line at middle of the dimension line. So here we have cut the dimension line at middle, and we should place the dimension value at middle of that cutting portion. So at this particular portion. So this type of dimension system is called unidirectional dimension system. I hope you understand. Thank you so much.